All right, so first of all, we want to remind you how to multiply with matrices. So the matrices look like this. Let's say it's 3, 4, 5, 6, and you have to multiply it by 7, 8, 9, and 0. Oops, something went radically wrong there. My alignment's off a bit, as it has been for the last week. All right, so if I'm going to take these guys and multiply them out, the first thing I told you to do was to tell what they were, and this is a 2 by 2, and this one's a 2 by 2. These are kind of no-brainer ones. Okay, and why? Because if these match up, then it can possibly be multiplied. Remember that a lot of them can't? A lot of people got to the problems at the end of the worksheet, and you're like, what? How can this be undefined? Well, it's because it wasn't matching up. Okay, let me show you a couple of those. Let's say I had 2, 3, 4, 5, 6, 7. And being multiplied by 1, 2, 9, 4. Well, first ask yourself, of course, they don't look like they would multiply. But, what's this? A what by what? 3 by 2. What's this one? A 1 by 4. And since these numbers don't match up, it will not work. Could I fix the one on the right to make it work? Yes, I could make it have 2 rows, so that this will be a 2 by 4. And I could make this like 7, 3, 8, for instance, and all of a sudden, yay, this one, even though they don't kind of look like they're going to match up, they will. All right, so you check and see what they are. Again, this is how many rows by how many columns. Always has to be rows first. And this is how many rows, 2, versus columns go this way, 4. And if this matches this, it's going to work. If it is going to work, then this tells you the type of matrix it'll come out with. This would come out with a 3 by 4 matrix. All right, so it'd have 3 rows and 2 columns. No, 3 rows and 4 columns, sorry. So that's going to be a really big answer. All right, so let's go back to my 2 by 2 at the beginning. I'd like you to just see if you remember how to do this, and do this by hand. Multiply this out on your iPad, and I'm going to show you how to do it on the calculator in a minute. Calculator can do these. And yes, it's a lot easier. This is something you will do in higher level math. It can be in pre-calc or in calc. You will run into matrices. All it is a nice little arrangement of numbers. Nice organized little set of numbers. In case you forgot, what you should be doing here is labeling your 2 by 2 matrix at the end, and it's got 4 spots. This one, this one, this one, and this one. And you should label them and say, oh, this is the row 1, column 1 spot. This is the row 2, column 2 spot. The harder ones are the other two. Mr. LD, could you tell me what the spot is right here? No, I'm asking, is it row 1, column 1, row 2, what is it? Row 1, column 2. Very good. In this last spot here? Yep. All right. Now, these are kind of like the directions to make the cookies. Mix row 1 with column 1. Stir. Row 1, column 1. And what goes together? The 3 and the 7 goes together. 3 and the 7, and then the 4 and the 9. 3 and 7 makes 21. 4 and 9 makes 36. 21 and 36 makes 50, what? 57. So, use your eraser on your iPad and make that 57. Figure out the other 3, and then I'll ask you in a moment. And I'm going to pause for a second to make sure everybody's staying with me on this. Do a little walkabout. We usually read them from left to right. So 57, and then what do you think's next? He says 24. Anybody agree with him? All right, good. That's a lot of hands. Probably right. How about the next one down here in the left spot? 89. That's a big number. Who got this 89? Okay, good. And the last one. Who thinks he hit the home run? They're all correct. Uh-oh. A lot of people are differing with you on that last one. All right. Who's got a different answer they think is right for the last one? What do you think? Who says 40? Ooh, a lot of people agree it's 40. Okay, let's just double check that. Last spot was row 2, column 2. That would be that with that. And the 8 and the 5 would make 40, and the 6 and the 0 make nothing. And you take 40 plus nothing is 40. Yes. How'd you get the 89? Okay, that one was row 2, column 1. So that one, I'll use the red. Row 2, column 1. Look at the two red ones I took. What? Because hold on. What's 5 times 7? 35. What's 9 times 6? 9 times 6? 54. Add them together. You get your 80. Okay? All right. Okay. Now, let's go back in time here. I'm going to hit the back button several times. And I'm going to get it back to the way it was in the first place. What if you knew how to do this in the calculator? Well, here's what you would need to do. You need to have two matrices, right? And they're both 2 by 2 matrices. And you got to have names for them because the calculator needs to know what to call them, and it uses really creative names. A, B, and C for the matrices. Okay, so we're going to call this matrix A. We're going to call this matrix B. And if you tell it then to multiply A times B, it'll do it. So how do we get matrix A to be formed? Give birth to matrix A. Right now, we want you to go into your calculator and go under matrix, which is right above this button. I'm going to make it turn red. See that button right there? Above that button says matrix. So I'm going to go second. And now I'm in the matrix menu. See A, B, C, D, and E, F, G? If you just hit enter, you'll be making it call up what matrix A is, but there isn't any matrix A yet. How do we edit it to make it? Go to edit, arrow over twice, doink, doink, and now I'm in edit. Which matrix do we want to edit? A, so you hit enter. And now I'm in the matrix menu. My matrix is 3 by 3 because that's what I had last hour as I was doing a 3 by 3. So I got to change that to a 2, enter, 2. That's a 2 by 2 matrix. And it's got some nonsense numbers in there. Yours might not have any numbers. Yours probably has zeros. How many of you have zeros for your matrix? Okay, good. If you're not with me, ask somebody nearby to get caught up. You really need to make sure you're in the right spot here. Any questions on where we are? Okay, now go ahead and enter. And our first matrix, we want it to be 3, 4, 5, 6. Remember, we read them from left to right. 3, 4, 5, 6. So I'm going to go 3, 4, 5, 6. Now, do you notice that mine has decimal places, and I bet yours doesn't? Mine says 3.00, 4.00, 5.00, 6.00. Why is that good? Because mine will only always do 2 decimal places. And yours, when we do some complicated things today, if we don't fix yours will have unlimited decimal places. And in the matrix, that is insane. It's impossible to read the matrix because the decimals go on so big. So, everybody right now, before I forget this, go to mode. Mode. Which one do you think I have different than yours? It's on float 2. Get yours on float 2. What that's going to do is it's going to make your answers always come out with 2 decimal places. It's the float menu. Go to float 2 and hit enter. I would change it to float 2 for right now, and then I would change it back later. Not that big of a deal. If you really want to mess with your friend's head, make it go to float 0. And what will that do? It'll always round your answers to whole numbers. So like if your answer was supposed to be like 3.14, it'll say 3.00. Or actually, no, it'll say 3. Anyway, it makes your calculator like really messed up because you can't do decimals anymore. But we want it to do 2 decimals, so we're doing float 2. Do you get that? Questions? Yes, sir. And that really won't make any difference right now. Radians are the more common setting than degrees. But the reality is most kids are not very good at radians, so I usually set mine to degrees. Okay. So, but for this, what we're doing today, it's irrelevant. Okay, so now I'm going to quit out of that. And now, get to your home screen and clear it. Just say clear. So you have a nice clear home screen. Now, get matrix A to come up on your screen. How do you do that? Well, first it's under the matrix menu. Matrix A, hit enter. And then how do I actually make it? I want to see it. What do I do? matrix, hit enter. And poof, there's my matrix. 3, 4, 5, 6. Now, granted, it's got decimals in it, but that's going to be good for later when we have like weird decimal, long decimals that'll round it for us. Okay, so how do we multiply that by matrix B? Well, we got to go in and edit matrix B. Go second, matrix, and then you go edit, a couple spots over, go down to B. Here I'm in, wait, I'm not in the edit menu. Yes, here we go, editing B. Okay, you there? Hit enter. And this is also a 2 by 2 matrix. And the numbers for this one are 7, 8, 9, and 0. Okay, so I go, yes, it's a 2 by 2. 7, 8, 9, 0. All right. Question. Okay, so now, what if I want to multiply them? Now I can go out of here, second quit, and I want matrix A. Go back into your matrix. You're constantly going in and out of the matrix menu. Matrix A times B, matrix B, enter. And there it is. 57, 24, 89, 40. Okay, now you know how to multiply matrices with a calculator. And I want to actually make sure that everybody got it right. So I'm going to make a quick sweep of the room and make sure yours is correct. It should be 57, 24, 89, and 40. Did it right. All right, so here's what I want to teach you that's kind of new. You already knew how to multiply matrices, or at least most of you. Now you can do it in the calculator, but what you need to learn today is what a multiplicative inverse is. Everybody shut your iPads. I want you fully with me watching this. All right? So, first thought. Do you get if I have the number 5 that I can multiply it by some special number and it will always come back to be 5 again? It'll keep its identity. What's the only thing I can multiply by? 1. But in matrix world, it's not 1. How do I get a matrix like 5, 6, 7, 8 to be able to multiply it by something and have it come back and be exactly equal to itself? And it's not 1, 1, 1, 1. You might think it is, but it's not. Any ideas? Not its inverse. That's something different. Let's talk for right now. We're talking about an identity. I can't just go times 1. I mean, that's cheating. Can't do that. Nope. Can't multiply it by itself. It gets way bigger. Multiplying it by 0 makes it disappear. Yes? Nope. Multiplying by a reciprocal. Let me say I had 7 and it times it by its reciprocal. What that does is it makes it equal 1. I don't want that. Nope. Not a trick question. All right. So how do I get this to be multiplied by 1 effectively? You go like this. If you multiply those two matrices together, you will get the original matrix back again. Let's prove it real quick. The answer for this will be a 2 by 2 matrix, right? And this spot right here would be row 1, column 1. So here's row 1, here's column 1. Multiply them together quick. You get 5 times the 1 and 6 times the 0. You get what's happening here? The 5 is going to stay there and the 6 is going to disappear, and then you go 5 and you put it right there, and that's what we had in the first place. See what's happening? All right, so let's hit the next one, which would be, this is over here, is row 1, column 2. So that would be like this. But that guy kind of moved. But okay, like that anyway. So 5 times 0 and 6 times 1. 5 times 0 makes the 5 disappear. 6 times 1 is just a 6, and that means that this would be a 6. You see how I'm getting this original matrix back again? All right, so this is called the identity matrix. It's like Neo in the matrix. It's a very special matrix. And what do you think if you had a 3 by 3 matrix? Can you picture what it would be? And then? Nope. And then? Yep. It's diagonal. Yep. That's called the identity matrix. That's a special matrix. That's like 1 in matrix world. Okay, now Let's talk about the other situation where you had like 9 and you want to times it by something, so you're going to get 1. What do you times 9 by? 1 9. What's that called? It's called its what? Not reciprocal. Inverse. I know reciprocal and inverse are a lot alike, but the word we need for this is inverse. Did you know there's a button for doing this? I know that's pretty easy, but you know, can you, if you wanted to have 9 and you wanted its inverse, do you know there's a button for that? It's this button. And you put it into the negative power, it flips it over, right? So the reciprocal of it, right? So, to keep your life simple, what we're going to ask you to do is, if you want the reciprocal of a matrix, so I want some matrix like this, 3, 4, 5, 6, and I want to multiply by some special thing, and let me tell you, it's really weird. This is hard to figure out in your head. So that it will equal the identity matrix, which is 1, 1, 0, 0, 1. If I want that to happen, I need to figure out this. You can let your calculator do the work. You're just going to use this button on this matrix. So, I'd like you all to put in this matrix, 3, 4, 5, 6. It's a 2 by 2 matrix. Put it in. Maybe you put it under C. That's a new matrix you've never used before. Make it matrix C. Going in here, going in the matrix menu. So I'm in the matrix menu. I'm going to go to edit C. Edit, go down to C. Enter. And I want it to be a 2 by 2, so I enter 2. And now I'm in the matrix. Mine's all zeros to start with, so I'm going to put in what it is. And this one is 3, 4, 5, 6. 3, enter 4, enter 5, enter 6, enter. Got my matrix in. That's matrix C. So now how do I do the inverse of C? I go out, clear off this completely, clean it. Inverse of C. First you put in C. So I'm going to go second matrix. I got to pull up the C matrix. Hit enter. See, I got C ready to go. Now I need the inverse of it, which is this button right there. The -1 power makes anything flip. Enter. And if you did what I told you before, where you have your decimals rounded, it looks like this. You're going to want your decimals rounded to 2 spots. You want to make your mode be float 2. Because otherwise your matrix, you can't even see all the numbers because this decimals are so long. All right. So what's special about this? If we multiply -3, 2, 2.5, -1.5. So I figured out by using my calculator what this special thing is. -3, and then 2, and then 2.5, and -1.5. If I multiply this times this matrix times this matrix, I get the identity matrix. I get basically like getting 1. All right. On your test, you will be asked to find the reciprocal with a calculator. All you have to do is add X to the -1 button. Easy. You have to know what it does. What reciprocal does, when you multiply them together, you get 1, or the identity matrix. Didn't even know it's called the identity matrix, because that's not really 1, is it? It's 1, 0, 0, 1. It's just a diagonal set of 1s. The rest are 0. So if it's a 4 by 4 matrix, it's just 1, 1, 1, 1 with all zeros and all the other spots. Oops, that's weird. And then there we go. There's a gigantic identity matrix for 4 by 4. It's just 1 down the diagonal. So, see? Everything else is here. All right. So let's start your homework together. Everybody, grab your iPad, get into it. Find the matrix day 3 is what it's called. It's under today's date, which is 5-7. And here we go. State the determinant. All right. Now there's 2 ways to do the determinant. You can do it by hand, and you can do it with the calculator, and to be totally honest, by hand is easier. let me show you how to do a determinant. A determinant is just, hold on, I got somebody at the door, I'm pausing. Okay, back to math here. State the determinant. All right, what do you do for a determinant? That times that. I know I just covered them up, but just stay with me for a second. Minus, for a determinant, it's subtract, that times that. It's sort of like cross multiplying. So yes, you can do this under the math part of your matrix menu. It says DET for determinant. It looks like this. And yes, you can do determinants that way, but it's way easier if you just know to go that times that, negative 6 times negative 6, which makes 36. And then subtract that times that. 6 times 0 is 6. No, 6 times 0 is 0. 56 minus 0 is 56. Why is my marker gigantic? 36. Yeah, that's a 36. Sorry, I couldn't even read it because it's so thick. Sorry about that. I'm going to pause for a second, figure my marker out. Okay, and what is this determinant thing good for? The only thing that ever matters on the determinant is a determinant determines if you can have an inverse or not. Some matrices can't have an inverse. If you do the determinant and it comes out to 0, then there won't be any way to do an inverse on that matrix. Heavy stuff. All right. Next part. State whether or not the inverse of the matrix exists. The reason I just said what I said is because what you're looking for is, will this guy's determinant be 0 or not? So just a real quick check of the determinant on this. Okay, so to do this one, I would go negative 9 times negative 2. How did it get gigantic again? Ugh. Okay, subtract this times this. The marker's really thick again. How did that happen? Negative 2 times negative 9 is positive 18. And so this is 9 times 2 is 18. Minus 18, which makes 0. Oh my gosh. When it comes out to 0, what happens? So there's no inverse. No inverse. So for 4, it has no inverse. Okay, let's try number 5. You should have said 0 times 4 minus negative 6 times 0. Well, 0 makes 0, minus 0 times anything makes 0, and it's 0. So this one does not have an inverse. No inverse on this one. This one, 6 times 4 is 24, minus 9 times 5 is 45. Is it okay if it comes out to a negative number? Sure, as long as it's not. Okay, so this one comes out to negative 21. Yep. There's the determinant, and that one will have an inverse. As long as it's not 0, it has an inverse. So this doesn't have an inverse. All right. Now remember, I told you that I would not ask you to find the inverses by hand, and therefore, on this next section, you may scribble off this thing that says no calculator. In other words, you can use the calculator. So I'd put this puppy in your calculator, and then I'd do the inverse on it. So let's say you call it matrix A, then you just got to go A to the negative 1, and it'll tell you the inverse. Okay.